Morning, everybody. Lights are shining pretty bright over here at me. Thanks so much, Rich, and to the show organizers for bringing this mind meld together. I've been a speaker at one of these events in Las Vegas. It's been a little while, so I'm glad to be back over here. Thanks particularly to you for committing your morning, especially in a city like Miami where you have so many other alternatives on the beachfront. So what I'm here to talk about is some very exciting work that IBM has been doing. And the reason I say exciting is that there is some genuine freshness to the point of view and the innovation that we've been considering based on many open source technologies, which I'll recognize in a few minutes, and also several pieces of IBM capabilities in it. The notion of a highly centralized environment in distributed computing, the notion of Internet of Things being device-centric, which is largely how it is right now as opposed to user-centric, the notion of business models around Internet of Things being based on devices and perhaps on data are sometimes clear and sometimes not entirely clear. Many of these notions are what have become barriers and have challenged the escape velocity that Internet of Things really needs to accomplish. Every year we hear that this is the year of the Internet of Things. And there are certain barriers that I'll talk about, but more importantly, I think you all have heard about the barriers, but more importantly, I want to come before you and provide the IBM point of view on a solution set that we have been prototyping as a project with some of our partners. This is a world that we call device democracy. There's also a paper that I'll tweet out later, and you can delve a little bit deeper into it, where it is a highly distributed, highly autonomous capability on certain technologies which we'll talk about, which Wall Street Journal actually has last week indicated in the financial sector. You all might have heard of Bitcoin, where Wall Street Journal has said that it is one of the most powerful platform to be created in the last 500 years in the financial sector. That's a pretty formidable statement to make. I'm not so much interested in Bitcoin, and that's not the purpose of the discussion over here. But it is some of the underlying pieces of it and what are the additional use cases that we can look at. So let's get into it. What we've been seeing at IBM, and many of our customers have adopted towards this, is not necessarily a split, but an integration of the duality of systems that has emerged in the last few years. And that is the system of records on the left side and the systems of engagement over on the right side. But more importantly, the integration between them, giving you insights to the systems, or the systems of insights. So the question now becomes, what is going to be the architecture and what are going to be the platforms which lend themselves to furthering the systems of insight, really the intersection in between? You've all seen slides like this. I'm not going to dwell on it, but if we look at what has happened with Internet of Things so far, for the most part, previous technologies, web-based technologies, have been repurposed into the scale of what is projected to be billions and billions of devices. Is that something which is going to scale? Is that something which is going to have the fruitful business models that the world is looking for? Okay. The Internet of Things for millions of things, the Internet of millions of things, is actually been in place for many, many decades. This is the area where heavy capital equipment is taken care of. Most of us traveled over here into Miami. Aviation, subways, trams, dams, high engineering systems, life-critical systems, the Internet of millions of things is already taken care of. But there is a portion which is ignored, and that is the Internet of billions of things. This is the middle layer in the pyramid, if you may, where there are things that are useful to us, but they have not necessarily have the smartness that we desire. These are things in our everyday lives, and you see and you've heard of the euphemism of a toaster and the smart toaster, but the euphemism behind that is things that we have to live with and that are part of our everyday lives. How do we innovate? How do we bring innovation into them? Now, for these kind of things, the approach towards Internet of Things has been a little bit challenged. And it is device-centric. It is, you would want something which doesn't necessarily have apps, doesn't necessarily have subscriptions. Would you want data to be picked up based on what kind of a toast you're having, today morning? Would you like advertisement to be burnt into your bagel, right? That's one model to get the right ROI and get the right business model. Is that an endurable, is that a sustainable model to bring innovation in a pervasive manner to the industry? Okay. So when we look at this, we look at four challenges that we see that are holding us back against massive scalable development in the Internet of Things. One is lack of functional value. The other is lack of ecosystem value. The third is invalid business models, kind of what I just spoke about a little bit. And then the fourth is the long-term operating costs. Okay. So let's look at these real briefly, each of these. When you look at functional value, what is most important is the usability, not just the usability, but the user interface and the user experience. Do I need one solution for my thermostats in the home and a separate solution for my surveillance and security system in the home and a separate solution for my appliances, so on and so forth, right? That really doesn't provide a seamless user experience. We will get some adoption, and that is not a good or bad statement. That is more a remark on the maturity of the industry. But what I want is a seamless solution from where I can manage, for example, a connected home or a connected car or the other connected anything that we've been talking about, we've been hearing about in the industry. So the user experience, the functional value and the user experience is what is most important, not device-centric behavior. The second is ecosystem value. Is the whole greater than the sum of the parts? How do you define the whole and how do you define the sum in the realm of Internet of Things? When you're dealing with billions of devices, when you're dealing with scores of devices individually within a home. What is the domain space which would define that this is the whole and this is a part? What is the domain space and what are the boundaries when you move from your home environment to a transportation environment into your work environment? How do I get seamlessness and what do I define to be what are the semantics and how do I define to be the whole and the part? What is the ecosystem? The third one I pointed out is the business model. So when we look at the business model, yes, it is about selling data. It is about monetizing data. But some of those goals and some of those visions are very aggressive. The example I gave you around burning advertisements into a toaster is kind of probably pulls it to an extreme. But if you look at this example of finding parking spots, right? Many cities have this struggle of, I'm forgetting the number, I was trying to think of the number in the city of San Francisco, I could be wrong, but I think it was something around 30% of, just energy wasted by cars is looking for, a parking spot. I could be wrong about that number, but there's a study that's been done, and it's a significant number, that's the main point. So, how do you find parking spots is one of the use cases that has been looked at. But what are the sources to get data around where the open parking spots are? How do you get the state of a parking lot or a parking garage or a parking structure? And you can get it through meters, you can get it through surveillance, cameras, you can get it through some aerial satellite drone photography. There are multiple sources of data. And when the supply of anything, when the supply of data and the supply of anything reaches infinity, the market price heads towards zero. How do you sustain a business model around around the economics such as that. And then the last barrier, the last blocking point that I talked about to giving the next big spur to Internet of Things is the operating cost. When you look at the longevity of devices, we are used to devices that are sitting in our pockets and we change them every year and a half. But when we talk about the Internet of Things, when we're talking about billions of devices, we are talking about devices that are going to be on a spectrum of longevity. The model to subsidize the cost of devices in order to sustain a business model and an ROI for Internet of Things is not necessarily the endurable, sustainable, economically sustainable model, even if you can build the technology and the architecture underneath it, which is what we have right now. Okay? So laptops, phones, right? You see the longevity of these. As the car becomes connected, it has more longevity. Things in the home don't get just replaced as frequently as your devices that we are used to, like our laptops and our smartphones. So you have to consider not just the economic, but the architecture principles on sustaining, doing upgrades, having control of a large portfolio and multiple versions of devices, or be able to compress on how many versions you're going to put out over there. So I think what I've been able to offer you, hopefully by now, are some of the challenges, and many of you came in over here probably knowing many of these challenges, that they exist. So if we were to look at this from scratch, what would we do? And we pondered over that, and we came up with, basically people want cool stuff. We want to make cool things. So the function has to absolutely lead. We want to play well with others, as far as the business model has to be endurable. And then we want technology that stands up to bullies. We want technology that is interoperable, it's resilient, it's decentralized, it's efficient, and it scales to the power that is needed for the seamless behavior and user experience that we talked about. Okay. So what is needed for this world that we are trying to get to, which is a world not of millions of not of millions of things, but the world of billions, or probably hundreds of billions of things? There are three pieces we identified that are very central to the model that we are proposing to the industry, and asking the industry to share experiences, share use cases, and come join us in solidifying this further. This is still in a prototype and a project kind of a stage. And the three pieces are blockchain, BitTorrent, and telehash. Many of you might have heard of telehash. Many of you might have heard of BitTorrent. It's been around. BitTorrent's been around for a little while. Blockchain is what is the underpinning of the Bitcoin technology, which I mentioned in the beginning. Okay. So I'll talk a little bit more about those technologies and how we weave that together in an architecture in just a few minutes. Let's look at Bitcoin, and then particularly blockchain. We're talking about, in Bitcoin, how many of you have heard of Bitcoin? All right. I hope you didn't come in here expecting to listen about Bitcoin. Because what we are interested in is the underlying technology of Bitcoin, and that is blockchain. Okay. So Bitcoin is this highly decentralized banking system where really there is no centralized bank. Okay. And it's a peer-to-peer, completely peer-to-peer model with trusted relationships, and not everybody in the ecosystem has to be trusted. That is one of the powerful aspects about Bitcoin. Only the majority have to be trusted. Okay. It is peer-to-peer in the sense there is no centralized authority. It is peer-to-peer in the sense that transactions are contained, or contracts are contained within programs on peer participants in the ecosystem. Something called smart contracts implemented through blockchain. What are smart contracts? Smart contracts are programs that enforce transactional relationship between any equivalent members of an ecosystem. I'll talk a little bit more about that in a few minutes. All right, if we look at the model in Bitcoin, underlying which is blockchain. And my interest here is to just set up the stage using Bitcoin because that's the more popular use case, but really then extract out of it the blockchain capability and see what are the use cases we can apply towards it. Transactions are confirmed by consensus. There is no single point of failure. So there is no centralized clearing house. There is no single point of failure. It's all in a peer-to-peer transaction relationship. You have smart contracts which basically ensure the trust in a transaction that has been initiated for transferring or sharing of assets. And as I pointed out, there's no need to trust all the participants. The longest blockchain, as long as there are majority, as long as there's a majority consensus, the longest blockchain wins. Actually, the numbers have shown that, just stepping away from the content of this particular slide, the numbers have shown that it's going to take almost 250 million of electricity and computing equipment in order to breach Bitcoin, right? So it's shown to be a very resilient from a trust standpoint, and there's a university that has done some of the analysis around this. So if you look at Bitcoin and you extract the Bitcoin portion out of it, then what you're left with is a generic transaction processing system that is programmable. It's highly scalable, it's peer-to-peer, and you begin to see the signatures and the signs and the design points that become pertinent for other use cases like the Internet of Things. What are transaction systems? You look at traditional transaction systems where you have travel reservations, billing systems, health records, so on and so forth. But also there are newer kind of transactions. So those are the ones that I just stated are the ones on the system of record side of things. And then you look at newer capability like social media, device data, which would be the case for Internet of Things, and documents. Those would be more in the systems of engagement side of capability. All these are transaction systems that require high scale. So I want to emphasize so that your takeaway is not one about Bitcoin. I want to emphasize that the technology we are here to discuss and the technology we've been prototyping with is blockchain. So you remove Bitcoin and you look at blockchain. And there's actually in the open source community, there's a lot of work being done around hardening blockchain, and I'll talk about one of the entities, open source entities that is doing that. So if we take Bitcoin, if we take the blockchain capability, and not just the blockchain capability, but the stack consisting of BitTorrent and Telehash, and I'll come to the purpose of each of those in just a moment, and place them on devices. You now have a core platform base, you have a substructure that can live on any device, to the extent the device is capable. Internet of Things devices come in different form factors and also different in terms of their capability as far as compute is concerned or storage is concerned or access is concerned. So not complete footprints of capabilities and features can necessarily reside, and that's why in a few moments you'll see a taxonomy of devices. So a suited footprint can reside on each of these. All right. So we can put a blockchain. I'm just calling it a blockchain stack. When I say a blockchain stack, I really mean at least at a minimum those three capabilities. When we put a blockchain stack, we can put it on a smartphone. We can put it on any embedded device. We can put it on a door lock. You can put it on a wearable. And that device then becomes a participant in the ecosystem. And you can build policies, and you can build control, and you can build user access on top of that, and more. So I'm not here to propose that the entire world is necessarily going to go into this peer-to-peer model. That is not the thinking. So we have to identify what is the sweet spot of the hundreds of billions of devices that the world is looking at. What is the sweet spot that lends itself to the model that we have been prototyping and that we are proposing to the industry to look at. If you look at the top left, these are highly centralized look at the axis first. And in this grid, you're looking at device value versus the device longevity that I pointed out earlier, because that has a very important aspect, not just to the architecture, but to the operating costs of the solution. At the top left is a highly centralized model. Right? So you look at device value with with low longevity. You look at RFID kind of sensors at the bottom left quadrant, right, which could lend itself to centralized models. So you've got low device value and low longevity of RFID, let's say luggage tags or those kind of things. And then the sweet spot for the model that we're looking at is where you have device longevity which is high, and the value of the device is anywhere towards medium to low. Okay. If you get towards the top right quadrant, you begin to look at a hybrid model. So you find the sweet spot when you're looking at your devices on where does the devices fit in the sweet spot economically from a business standpoint, and then you look at the corresponding architecture to go after. Okay. Let's look at some of the business models. That's the second thing I want to talk about that plays well with others. We've seen digital projects turned into liquid assets. What we are now looking at similarly, some examples of those are Amazon. We've seen what's happened to music. There's an example from China, so on and so forth. So we've seen music, and of course currency, cryptocurrency through Bitcoin. So we've seen digital assets turned into liquid. And once you take a digital asset and turn it into liquid, you can apply multiple economic transactions to it for sharing and transferring of assets. We believe that the Internet of Things will do the same things for the physical world. So you take the physical world and lift it into a software stack, and that is the stack that we are talking about over here. And now you've made those physical assets liquid. Once you've made the liquid, you can do all sorts of things to it. If you can tag it, you can manage it, and you can apply transactions to it. When you apply transactions, you can begin to share it, you can begin to transfer ownership, you can control access, you can control experiences. Okay. This is already happening. We are seeing this happen, but it's happening in a little fractured manner. Examples of Estimote, examples of smart door locks, and then of course payment mechanisms around that. We are seeing it in companies like Uber and other ways for more efficient transportation. These are not necessarily peer-to-peer models, because you still need a company like an Uber to ensure the governance around the assets that become part of its ecosystem. Right? So what you're looking at is a similar capability where you take the physical assets, lift it into a layer of software capability, and now those assets become liquid and you can do different transactions and different treatment to them. Okay. Except that we are talking about a highly distributed and peer-to-peer model. The use cases from that then become amazing, and we've seen some of those from examples like Uber, and that's not the only one. There are other companies that are in a similar space. If you look at the results from what has been proven in the market, the average taxi utilization is around 55%. Uber fares are 18% lower, yet their drivers make 22% more income. You see the disruption. You see the disruption over here. Okay. So this is not just traditional device function that can be distributed and traded. So it's not restricted to compute cycles and storage and utility, electricity. We've seen the distribution of these assets in place and very well assimilated and very well adopted. So we can apply similar behavior and similar patterns. We can derive similar behavior and similar patterns from physical assets by putting a seamless, interoperable stack which provides the business models that we're looking for. All right, I'll skip through the slide. I had some more examples over there. So let's look at the technology aspect over here. I'm guessing there might be some developers that hopped over from IoT Evolution or M2M side of the conference. So I'm going to get into, the reason I have this is to dive a little bit deeper into the technology aspects that I talked about, but also to share with you that this is not just a white paper. This is an architecture that we have stood up. This is an architecture we have prepared. In fact, there's a practitioner paper that is already on a pre-release from the Consumer Electronics Show a few weeks back, and there is a prototype that we've been working with some of our customers that we have stood up. So if you drill into the architecture of what we call ADEPT, okay, autonomous decentralized peer-to-peer telemetry. At the highest level, the architecture consists of this stack. The core blockchain, which consists of blockchain, BitTorrent, and telehash. There are other candidates in that space that we are looking at for file transfer and for messaging particularly. Blockchain by itself is almost unmatched in the industry in the capability that it brings to us. And on top of that, you have coordination and analytics. This is where there's been a very significant challenge and the gap in the industry on how do you do coordination of devices. Because until you have the coordination of devices, you can't get the seamless experience on top. And that's the application and also the marketplace, which is one of the things around the business model and the ROI. So I alluded earlier to a taxonomy of devices. This is the taxonomy of devices in a rough sense. A light peer, a standard peer, and a peer exchange. A light peer is something which is not very muscular in its compute capability, and you put a minimalistic core blockchain stack on a light peer. Okay? It provides messaging, it knows about certain peers, it can do file transfers, and then of course it has blockchain. You cannot participate in the ecosystem without having the blockchain core capability. You look at a standard peer, it has a little bit more capabilities, autonomous device coordination framework capabilities. It has, some analytics capabilities. Now, one of the things you also begin to look at over here, in a peer-to-peer environment, when you're moving away from largely centralized environments, not everything necessarily has to go to a centralized entity to do all the analytics. There's some aspects of analytics that can be done on the device. Okay. And then there's some aspects of filters and policy that you can write on the device which will gate what kind of data and at what intervals and at what events, what triggers, should the data really be sent up to a centralized point. And I wouldn't say centralized, to a more capable point. Let me just say a more capable point, a more capable node. Okay. So the third part of the taxonomy is the peer exchange. So if you can get a hum by connecting a device, that is the minimum condition you need, right? And then you begin to put a stack on top of it, and you begin to have transactional relationships with other devices or any other nodes in the ecosystem. And you can also pipe events coming from those devices into a commercial marketplace for reordering, for access, for brokerage, for transfer. So you look at a life cycle. You look at devices from a life cycle as part of that marketplace. In that marketplace, you can have OEM participants, you can have distributor participants, you can have supply chain participants in that life cycle, in that marketplace. And then, of course, you can do more analytics, more rigorous analytics and business intelligence in that marketplace. Okay, let me just build this slide up. So you can look at it. I'm sorry. So this is the architecture of the ADEPT implementation that we are looking at. And the main thing I put this slide together is so you can see the amount of open source pieces in this. This is the larger picture. What I've done in some of my closing slides, I've called out and highlighted few key open source technologies, and in all disclosure, a few key IBM technologies also. I have only one product chart in my entire talk. Okay. So if we look at it from the bottom, let me just take a minute to kind of step you through this slide. If you look at it from the bottom, that's your physical access layer. And you can have whatever protocol, there's no dearth of it, there's a lot of work done at the protocol layer and the access layer. Zigbee, Bluetooth, Wi-Fi, iBeacon, so on and so forth. Okay. And this is within small environments. And if you have to reach out over the wide area, then of course you have MPLS and other technologies. You look at the layer above that. I mentioned Samsung over there because that's one of the partners that we are working with in the prototypes that have come together. I'll talk about some of the prototype work in a few minutes. It could be any OEM. It could be any Arduino, Raspberry Pi board, Beagle board for any embedded device. And then on the right side, if you look at the right side, it also puts in perspective what the role of cloud is in this architecture and in this solution. Okay. So you could have heavy compute being done, and the marketplace could be stood up on a backend cloud. You look at the next layer. Pick your favorite data store. We are working with MySQL right now, and then more importantly, not just infrastructure as a service, but platform as a service. There are a few open source pieces towards the middle right part where it says PaaS, Platform as a Service, and that is Cloud Foundry. And there's an IBM product called Bluemix, which is based on Cloud Foundry, and that's one of the things I wanted to highlight. And then you look at the next layer up. That's what I've been referring to as the core blockchain stack, and that is Telehash for message services, the leading candidate that we've been working with right now. For asset and trust services, blockchain, and then particularly Ethereum that we've been looking at and have done a certain port of Ethereum over to a Java version of it running on Android. And then BitTorrent for file sharing capability. Now, once you have this substructure, you begin to build applications, killer apps, marketplaces for commerce on top of it. And that could be for a connected home, connected car, connected whichever sector. And you now have the foundations for seamless experiences, for seamless user experiences. All right. I'm about to wrap up with my last few slides. This is obviously not so much for legible consumption, but to tell you that this is not just charts and not just a white paper. This is an implementation. This, in fact, is an Ethereum client. For those of you sitting in the front and care to read it in hex, there are actually two peers in this, and the two blocks that have been identified in the if you look at the top left, the second box from the left, you'll see block 1 and block 2. That's how the blockchain is being built. But the point really being the following: this is actual implementation and a prototype that we've stood up, and the few use cases that we've been working on with Samsung in particular, and that is for the smart washer and for AdCast, which is for advertisements on devices, okay, on LED devices. So this is some of the code for the smart washer, and I wanted to highlight this one particularly because once you don't want to just put a connection that your washer is on or off or something, but you now have the opportunity to build pipe this into a marketplace that if it needs detergent, it could be reordered. If it needs a certain part which is predictably coming up for failure, that could be reordered. So there's lots of other apps and use cases around this that you can build. Last two slides on highlighting a few important pieces and also to recognize tremendous work that has been done from which we are building up in making that open source capability, bringing it to IoT use. Blockchain I mentioned, which is what underpins Bitcoin. Raspberry Pi is the board that we started out with for our prototype and then have it on other Samsung boards, and Ethereum that we've been working with also. And, Vitaly, I just want to be sure I pronounce the names properly. Vitaly Buterin is the creator of Ethereum. Ethereum is doing a lot of work in hardening blockchain. And he was looking at some of the work that we were doing and the demo that we had at CES earlier this month. And then, of course, Bitcoin. Its inventor is very well known, Satoshi Nakamoto. So a lot of work has been done by the open source that we are able to leverage. I've highlighted only two pieces from the IBM capability. One is IBM Bluemix. And the reason I highlight IBM Bluemix is this is also getting to be where a lot of our development is going to move to, is going to happen. And IBM Bluemix is a PaaS. The other reason I highlight is because it's based on Cloud Foundry, which is open source. That's an open source, the leading PaaS, leading open source PaaS. And IBM Bluemix runs on IBM software, which is the underlying infrastructure as a service, right? So this is the cloud portion of an ecosystem. We intend to bring the blockchain capability and also make this a community destination from where services and code would become available. And by the way, I didn't mention over here, but we would also make GitHub code available on GitHub. Well, I mentioned it on this page. So this is my last slide. I want to leave it for you to. I want to invite you to come engage in the excitement that we have. We think that this is very disruptive. We feel that this is a very fresh way of looking at the market on bringing an innovative solution that can scale without necessarily any one company or vendor controlling it, and also not necessarily being a largely centralized environment where you have the opportunity to do peer-to-peer transactions, but at the same time there is capability of large compute, large storage available via the cloud in combination with compute and capability and analytics and participation available at the device level itself, self-contained at the device level. Okay? So I know you guys gave up a lot in bringing yourself very early in the morning over here, and what I had promised to myself to bring to you is a fresh perspective on how to look at the Internet of Things. I hope you enjoyed it.